Okay, 3a, sine 2 theta. Now, as long as you know what the equation is, the formula. Right, there we go. So, now we have secant theta is negative root 3. We also have sine is positive, okay? Now remember, secant is one over cosine. So if cosine's negative and sine is positive, it must be this quadrant here. Anyway, let's take a look at this. So, I'm going to come up here. So cosine theta is negative 1 over root 3, okay? Again, just reciprocal of secant theta. Now I need to, I suppose I might just leave it like that for now, okay? I'll leave it like that. Okay, so if that's the cosine theta, now that means, okay, here we go. So that means that if this is root 3, this must be 1, again, because remember, cosine theta is adjacent over hypotenuse. In other words, what is this? So I can find out what sine theta is, the opposite over hypotenuse, okay? So, as long as you understand what I'm doing here, okay, remember, based on that, if this is cosine, that's adjacent over hypotenuse, root 3 must be the hypotenuse, 1 must be adjacent, so what's opposite? Pythagoras' theorem, okay? I'll call this x. Right, so 1 squared plus x squared is root 3 squared. Root 3 squared is 3, okay? So can you see that x squared must be 2, so x must equal root 2. Okay, so this here is root 2. So therefore, the sine of this angle must be root 2 over root 3, opposite over hypotenuse. So sine, I'm going to write down as, well, we've got the cosine there, okay? And the sine is, remember, it's root 2 over root 3. So I'm going to plug everything now into the formula. 2, what's sine theta? It is root 2 over root 3. What's cosine theta? We've already got it here. Negative 1 over root 3. Okay, that's sure it's negative. Negative inside, sorry. Okay, there you go. Right, so what do we have here? Inside, root 2 times 1 is root 2. Root 3 times root 3 is just 3. We've got the 2 outside. So I guess that's the answer. 2 root 2 over 3. Okay, that's what sine 2 theta is. Right, let's take a look at question 4. Some space up here to do some work. Again, right, cosine half theta. Right, again, as long as you know the formula. So if secant theta is root 5, that means cosine theta, right, cosine theta is 1 over root 5, okay? Again, because that's secant theta. Sine is positive, so is cosine. So we must be looking at, if everything's positive here, then everything must be in quadrant 1. Okay, so let's take a look at this. Now I'm going to rationalise the denominator for this. In other words, I'm going to multiply by root 5. So this is actually root 5 over 5. That's what cosine theta is, okay? So let's plug it into this. We have the square root of 1 plus root 5 over 5 over 2, okay? Now, that, I'm going to go up here. That will, let's have a think about this. Common denominator, right. 1 is 5 over 5 plus root 5 over 5 all over 2. So I have 5 plus root 5 over 5 all over 2 inside, okay? Well, that's going to become 5 plus root 5 all over 10, okay? That goes inside with the, so the 5 and the 2 kind of go together here. And I think that's it. Is that it? It's a positive. I don't know if it wants any more, but that, as far as I'm concerned, seems to be okay. Okay? Right, let's see if we've got any more questions. Right, solve these. Okay, square both sides. 3x plus 1 equals x squared minus 2x plus 1. I just squared both sides. Remember, x minus 1 times x minus 1 is a FOIL. Right, set everything equal to 0. So take away 3x from both sides. Take away 3x. I get negative 5x. Take away 1 from both sides. Oh, that's it. Okay, that's it. That's what I've got. So factoring x out. I get that. So my two solutions should be 0 and 5. But if I put this back, the 0 is not going to work. If I put 0 into there, right, 0 plus 1. The square root of 1 should be 1. But if I put 0 in here, it's going to get negative 1, isn't it? Yeah? Okay. Does 5 work? 60. Yeah, 5 does work. Okay, so that's just me checking. So that's the only one that actually works, the 5. Okay, don't forget to check your radicals. Don't forget to check your rationals as well. Right, let's keep on going. Now, actually, I'm not going to do this one because that's just the quadratic equation formula. A equals 4, B equals 4, and C equals 5. All right? So, this next one. All right, the common denominator is x squared. All right? The common denominator is x squared, just like the common denominator of 2 and 8 is the 8, because they'll both divide by 8. Okay, the common denominator is the x squared. So let's multiply everything by x squared. So this gets multiplied by x squared, that gets multiplied by x squared, and that gets multiplied by x squared. So I'm going to have this. Because x's cancel in the first one, I'm going to have x, 6x minus 7, minus 1 equals 5x squared. I multiplied everything by x squared. Again, just one of the x's cancel here to leave me with this x. Right, so 6x squared minus 7x minus 1 equals 5x squared. Let's take away 5x squared from both sides. Take away 5x squared from both sides, you are going to get x squared minus 7x minus 1 equals 0. Yuck. Oh, is that the quadratic equation formula? Apologies for this one. I'll try and get something that will maybe factor nicely and you can check it. But that, to me, unless I've done something wrong, looks like the quadratic equation formula. Anyway, so onwards. The last one. Absolutes. X minus 4 is less than 1, and x minus 4 is greater than negative 1. Okay, remember the rules? Just change direction of the inequality and change the sign. Add a 4 to both sides. X is less than 5. Add a 4 here. X is greater than 3. So interval notation would be, well, it's just like this. 3 and 5, okay? It's in between 3 and 5. That's it.